We'll be discussing some other topic relating to switching. We call it as a spanning tree protocol. Now, spanning tree protocol is used to stop the loops generally whenever you have some multiple links between the switches. So we'll see how the spanning tree is going to work, how it's going to prevent the loops in the network, and why there is a possibility of loops in the network, and the different step-by-step procedure on how spanning tree is going to prevent these loops. So the first thing we'll be discussing what is exactly bridging loops and when in which situations there is a possibility of bridging loops. So let's take an example. I got some 40 devices connected in the LAN and I have a switch which is just a 24 port switch. Now you got a switch here, and normally if you have some device with a 24 ports, in general we cannot connect all the 40 devices on a 24 port switch. We can maximum connect up to 24 devices. Now probably what we do is we can go with another switch which is again a 24 port switch, and I can connect some 20 devices on a switch 1 and the remaining 20 devices on a switch 2, and we can have some cross cable connecting between this switch. Now this is how we extend the LAN. When I talk about 200 devices, it doesn't mean that we are using a single switch with 200 ports. So we might be using multiple switches, and at the end it will be considered as one LAN. Now the major problem with this one is what happens if the link fails between the switch. Now if that link goes down, automatically the users connecting on the switch 1 will not be able to communicate with the users on the switch 2. So which means these two network segments cannot talk to each other. Now to prevent this single point of failure, because there is a single point of failure, and to prevent that single point of failure and to provide some redundancy, what we can do is we can add one more link connecting between the switches. That's something recommended. At least 2 or more than 2 recommended to connect, but minimum you can have one link. Now the good thing about adding 2 links between the switches is it's going to provide an option of redundancy. Redundancy is an option where if any one of the link fails, still you have an alternate route for communication. Now if this link goes down, still we have an alternate route where the users connecting on the switch 1 will be able to communicate with switch 2. But one of the major drawback with this one is it will also create the loops. It still create the loops if both the links are working. So let's take an example. If both the links are working, in this scenario, if I just assume that I got 2 links and both the links are working fine. So this link is still up. Now initially the switches will do broadcast for the first time. So if any one of the ports sends a broadcast, the broadcast goes to all the ports. Also it will go on this port, and then the switch 2 will propagate the broadcast again back on this port, and then it will come back on this port and then this port. Now what is happening here? This is what we call as bridging loops or a continuous broadcast. We call this as a broadcast stops. So adding 2 links between the switches provide us the good thing about something called redundancy, but at the same time there is a possibility of loops when you have multiple links between the switches. Now it's a continuous broadcast stops, and this broadcast will not stop unless and until you remove any one of the link or the network goes down. So we call this as continuous broadcast stops. Now even multiple links also, because of the continuous broadcast, the MAC table will not be stable. It keep on updating based on the continuous broadcast messages. And also there is a possibility that multiple frame transmissions over multiple sites. Now these are the general problems we have in general if you add 2 or more than 2 links between the switches. Now we call them as bridging loops. Now we need a solution for this, right? So at the end we need a solution which is going to provide the redundancy at the same time prevent the loops. So there are some possible solutions we can think about to stop this one. When I'm connecting 2 links, I can just have only one link between the switches. Just adding one link, no more extra links. So only one link, but the problem with this one link is it's not going to provide me the redundancy option. If that link fails, simple, the users on the switch 1 will not be able to communicate with the users on the switch 2. Now, this is something I don't recommend. In general, we don't want this solution. We need to have a solution which is going to provide us the option of redundancy. At the same time, it is going to stop the loops. So let's see what are the other alternatives we can think about. So we can have multiple links and we can temporarily close or shut down the one of the link. So just like we have two exits, we have two paths, and what we are doing is we are temporarily closing the one of the path. We are not using it. So that is something manually it's not possible again, because manually shutting down the port, no shutting down, it's something really not applicable. But I can also expect that to happen automatically by using a protocol called STP. Now STP, what it is going to do is it is going to find the redundant links in the network. So in my scenario, I got just two links, 1 and 2. You can have more than two links. Let's say I have 4 links. Just assume that we got 4 links connecting between the switches, link 3 and link 4. Now STP will figure out how many links, redundant links you have in the network, and then STP will ensure that any one of the link goes into forwarding, and automatically the remaining links goes into blocking state. Automatically, which means they will not forward any traffic, and it will ensure that only one link is forwarding and all the remaining are blocking state. Now in case due to some reason, let's say the main link goes down due to some reason, so which means this link is not forwarding the traffic, it will automatically make the other link to forwarding, because the first link is down and the remaining three links are automatically, they are down, not immediately, after some time, but it happens automatically. If that particular link also goes down, now this link is down, this link is down, it will make the third link into forwarding after some time, somewhere around 50 seconds of time, and it will ensure that there is only one link up and running, one link is forwarding, and automatically all the remainings are into blocking state. So that's what STP is going to do, and that is what we are going to learn here, how it's going to do this job. So STP is going to prevent the loops by ensuring that there is only one link in the forwarding and all the remaining links into blocking state.